Hello everyone. Today's video is on one of the most common question types in exams, that is solving exponential equations and finding the value of the variable x. Most of the students leave out such questions thinking that they are complicated, but the truth is, if you have your basics correct, solving such questions is no big deal. In this lesson, we are going to learn the basics behind exponential equations and practice ample number of questions. In fact, we are going to solve all the questions that you can see on the screen. And I am sure that after this video, you will be able to attempt these questions confidently. So friends, since we are dealing with exponential equations, here is the complete list of the rules of exponents. Sometimes we call them laws of indices. At any point, if you get stuck during the video and want to recall the exact rule to apply, you may use this page as quick reference. Now have a look at some basic equations involving exponents. These two. While solving an equation, if we come across something like x raised power a is equal to x raised power of b, meaning if the bases on both sides of the equation are equal, then that means for that equation to hold, the powers should also be equal. A should be equal to b. And likewise, if powers are equal, then bases must also be equal. With these basics, let us start with the concept of exponential equations. First things first, what do we mean by the term exponential equations? Well, an exponential equation is an equation in which a variable is in the exponent. For example, look at the following equation. 4 raised power of 2x plus 1 is equal to 64. We know that in such numbers, this is called the base, while this number is called the power or the index or the exponent. Clearly, the base, the number 4, is a constant and the variable x is a part of exponent. So such an equation is called an exponential equation. Next, we would like to know how to solve an exponential equation. So friends, the steps to solve such equations are quite simple and straightforward. An equation is made up of many terms on the left hand side and on the right hand side. The first step is to identify the common base. Like we can see, the left hand side is 4 and right hand side is 64. 64 is equal to 4 into 4 into 4, or we can say 4 cube. So over here, the common base is 4 on both sides. We will take the smaller number as base because that keeps our calculations simple. Next step is to rewrite both sides of the equation with the same base. We write 4 raised power of 2x plus 1 is equal to 4 raised power of 3. Now we know that if the bases on both sides of the equation are the same, the exponents must also be equal to each other. So the third and the last step is to set the exponents on both sides equal to each other and solve for the value of x. The exponents are 2x plus 1 and 3. Let's equate them. 2x plus 1 is equal to 3. 2x is equal to 2, and that means x is equal to 1. That solves our equation. Let us practice these steps on a few more questions. Now we are going to try out our first practice question, which is 7 raised power of 3x plus 5 is equal to 49 raised power of x. And we have to solve for the value of x. The first step in these questions is to identify the common base. We have 7 on the left hand side and 49 on the right hand side. As we know, 49 is the square of 7. So our choice of base should be 7. And we can write 49 as 7 square. So our same equation now looks like 7 raised power of 3x plus 5 is equal to 7 raised power of 2 whole raised power of x. Now how do we simplify this? Well, when we have a power of a power, something like a raised power of m whole raised power of n, it is equal to a raised power of m into n. Therefore, 7 raised power of 2 whole raised power of x is equal to 7 raised power of 2 into x. Let us use this result and we get 7 raised power of 3x plus 5 is equal to 7 raised power of 2x. Since the base is equal on both sides of this equation, this means the exponents are also equal. So let's equate the powers on both sides. 3x plus 5 is equal to 2x, and rearranging the terms we have 3x minus 2x is equal to 5. Therefore, x is equal to 5. Next question is 5 raised power of 3x minus 2 is equal to 125 raised power of 2x. We have to find the value of x. As always, the first step is to identify the common base. We have 5 on the left hand side and 125 on the right hand side, and 125 is the cube of 5. So the number 5 is the best choice of base, and we can write 125 as 5 raised power of 3. So we can rewrite our equation as 5 raised power of 3x minus 2 is equal to 5 raised power of 3 whole raised power of 2x. Again, using the power of a power rule, a raised power of m whole raised power of n is equal to a raised power of m into n. So 5 cube whole raised power of 2x is equal to 5 raised power of 3 into 2x, which is in turn equal to 5 raised power of 6x. So our equation now looks like 5 raised power of 3x minus 2 is equal to 5 raised power of 6x. And the base on both sides of this equation is the same, it's the number 5. This means the exponents are also equal. So 3x minus 2 is equal to 6x. And rearranging the terms, we have 6x minus 3x is equal to minus 2. 3x is equal to minus 2. Therefore, x is equal to minus 2 upon 3. In the third question, we have to solve for x if 27 raised power of 2x minus 3 is equal to 243 raised power of 3. So just keep in mind that we have to identify the common base first. On the left hand side, we have the number 27, which is 3 cube. So while figuring out the base for number 243, we should quickly check if it's a power of 3, right? And indeed, 243 is 81 into 3. It is 3 raised power of 5. So that's it. Our choice of base should be the number 3. Let us rewrite this equation in base 3. 27 is 3 raised power of 3 and 243 is 3 raised power of 5. So we get 3 raised power of 3 whole raised power of 2x minus 3 is equal to 3 raised power of 5 whole raised power of 3. Again, we can use the power of power rule of exponents to simplify this equation. A raised power of m whole raised power of n is equal to a raised power of m into n. So on the left hand side, we have 3 raised power 3 whole raised power of 2x minus 3. Now the powers combine as follows. 3 into 2x minus 3 is equal to 6x minus 9. So we have the term equal to 3 raised power of 6x minus 9. And on the right hand side, we have 3 raised power of 5 whole raised power of 3, which is equal to 3 raised power 15, because 5 into 3 is 15. Our equations get simplified to 3 raised power of 6x minus 9 is equal to 3 raised power of 15. And since the bases on both sides of this equation are equal, we can equate the exponents also. 6x minus 9 is equal to 15. So 6x is equal to 15 plus 9. 6x is equal to 24, which means x is equal to 4. And that's our answer for the given exponential equation. Next, we have a question which is slightly different from the previous 3 questions. We can spot the variable in 2 of these terms, and the right hand side is a constant. So generally, what we do is, we club these 2 terms on the left hand side by identifying their common base. and we ignore the constant term as of now. So we have 2 and 4. Since 4 is equal to 2 into 2, 2 is the perfect choice for base. Rewriting the equation, 2 raised power of 2x plus 3 plus 2 raised power of 2 whole raised power of x is equal to 72. 2 raised power of 2 whole raised power of x is equal to 2 raised power of 2 into x. And how do we simplify this term? We can use the product rule of exponents, which says that a raised power of m plus n is equal to a raised power of m into a raised power of n. So 2 raised power of 2x plus 3 is equal to 2 raised power of 2x into 2 raised power of 3. Using this, our equation now looks like 2 raised power of 2x into 2 raised power of 3 plus 2 raised power of 2x is equal to 72. We can take 2 raised power of 2x common out of both terms. So 2 raised power of 2x into brackets 2 raised power of 3 plus 1 is equal to 72. 2 raised power of 3 is 8 and 8 plus 1 is 9. So 2 raised power of 2x into 9 is equal to 72. 9 8s are 72. So the same equation simplifies to 2 raised power of 2x is equal to 8 and 8 is 2 raised power of 3. Base is 2 on both sides, so exponents can be equated, which means 2x is equal to 3. Therefore, x is equal to 3 by 2. That's our answer. Fifth question is similar to question number 4. You may pause the video and try it out on your own, and once you're done, let's discuss. So the exponential equation given to us is 3 raised power of x plus 1 plus 3 raised power of x minus 1 is equal to 270. Base is clearly 3 and we should try to combine these two terms on the left hand side. Using the product rule of exponents, let us simplify these two terms. We know that a raised power of m plus n is equal to a raised power of m into a raised power of n. So 3 raised power of x plus 1 is equal to 3 raised power x into 3 raised power of 1. And 3 raised power of x minus 1 is equal to 3 raised power of x into 3 raised power of minus 1. Or you can use the quotient rule also to simplify this. It's totally up to you. Rewriting the equation, we get 3 raised power of x into 3 raised power of 1 plus 3 raised power of x into 3 raised power of minus 1 is equal to 270. Further, 3 raised power of minus 1 is equal to 1 upon 3. This rule I always remember. A negative power can be converted into a fraction. So in our equation, we can take 3 raised power of x common from both terms on the left hand side. 3 raised power of x into brackets 3 plus 1 by 3 is equal to 270. And 3 plus 1 by 3 is equal to 10 upon 3. So let us simplify our equation. 3 raised power of x into 10 upon 3 is equal to 270. Cancel 10 on both sides and take 3 to the right hand side. So 3 raised power of x is equal to 81. 81 is equal to 3 raised power of 4. So if 3 raised power x is equal to 3 raised power of 4, then x is equal to 4. Next question is a very good one, though it's slightly complicated. If you're able to do this question without any help, then I'm sure you can tackle any exponential equation comfortably. Let us discuss. We need to combine these two terms on the left hand side, and the best choice of base is 9 because 81 we can see is 9 raised power of 2. It's 9 square. So let us rewrite this term as a power of 9. 9 raised power of 2x minus 1 minus 9 raised power of 2 whole raised power of x minus 1 is equal to 1944. Let me repeat. A raised power of m whole raised power n is equal to a raised power of m into n. So 9 raised power of 2 into x minus 1. 2 times x minus 1 is 2x minus 2. So our equation is 9 raised power of 2x minus 1 minus 9 raised power of 2x minus 2 is equal to 1944. Further, using the product rule of exponents, we break up these two terms. A raised power of m plus n is equal to a raised power of m into a raised power of n. So 9 raised power of 2x minus 1 is equal to 9 raised power of 2x into 9 raised power of minus 1. And 9 raised power of 2x minus 2 is equal to 9 raised power of 2x into 9 raised power of minus 2. So 9 raised power of minus 1 we know is 1 upon 9. And 9 raised power of minus 2 is equal to 1 upon 9 square. We can take 9 raised power of 2x common from both terms and we get 9 raised power of 2x into brackets 1 over 9 minus 1 over 81 brackets close is equal to 1944. Now 1 upon 9 minus 1 upon 81 simplifies to 8 over 81. And we can simplify this equation by dividing both sides by 8. 8 into 243 gives us this number 1944. So 9 raised power of 2x is equal to 243 into 81. Now here it's a very tempting thought that right hand side should be a power of 9 because till now we have taken the base 9 and it has worked well for us. But no, right hand side is not a power of 9 but it's a power of 3. 243 is 3 raised power of 5 and 81 is 3 raised power of 4. So instead of converting right hand side into a power of 9, we convert left hand side into a power of 3 because 9 is 3 square. So our equation is 3 raised power of 2 whole raised power of 2x is equal to 3 raised power of 5 into 3 raised power of 4. 2 into 2x is 4x. So 3 raised power of 4x is equal to 3 raised power of 5 plus 4. That is 3 raised power of 9 on the right hand side. 4x is equal to 9 which means x is equal to 9 upon 4. That's our answer. So far we have dealt with exponential equations that were linear. But if you have studied quadratic equations as a part of your math syllabus, then occasionally we might face exponential equations which are convertible into quadratic equations. For instance, take the equation 5 raised power of 2x minus 5 raised power of x is equal to 20. Rewriting this, we can see that the first term is clearly the square of the second term. So to solve this equation, we can take the substitution 5 raised power of x is equal to y. By doing so, the original equation reduces to a quadratic equation. If 5 raised power of x is equal to y, then 5 raised power of 2x is equal to y square. So after substitution, our equation looks like y square minus y minus 20 is equal to 0. Minus 20 can be written as minus 5 into 4. So we can use the factorization method to solve this quadratic. Split the middle term. Minus y, write it as minus 5y plus 4y. Club the first two terms and club the next two terms. And we get our two factors as y minus 5 into y plus 4 is equal to 0. So in this equation, if y minus 5 takes the value 0, then y is equal to 5. Else if y plus 4 is equal to 0, then y is equal to minus 4. But think, what is y? Y is equal to 5 raised power of x, which is always greater than 0 for any real value of x. Therefore, y cannot take the value minus 4 and y should take the value 5. So let's resubstitute the value of y. Y is equal to 5 raised power of x, which in turn is equal to 5. 5 is the same as 5 raised power of 1. Therefore, x is equal to 1. This is our answer for the given exponential equation. That brings us to an end of this video lesson. If you enjoyed it and found it useful, don't forget to press the like button And also do subscribe our channel. Here is a glimpse of other popular maths videos on our channel. Stay tuned and happy learning. Bye-bye.